Welcome back to Triptych Algebra. Today we're talking about literal equations, which are also called formulas. Literal equations are equations where we will have more than one variable and will be asked to solve for one of the variables. In this case right here, we're being given 3x minus 2y equals 9, and we're being asked to solve for x. Before I do that, I want to just remind us of solving equations in one variable. When solving a one-variable equation, in this case, my first step would be to add 6 to both sides. I'm adding 6 to undo the subtraction of 6 that's occurring to my variable. Again, think about this idea of isolating the variable. When solving one-variable equations, we isolate the variable by performing the opposite operations that are occurring on that variable in the opposite order. Specifically here, I have 3x minus 6. The first thing I'm going to do is add 6 to undo the subtraction of 6. When I do that, the right-hand side of my equation, I'm adding 6, becomes 15. Now I have 3 times x equals 15. I divide by 3 to undo the multiplication of 3, resulting in a final answer of x equals 5. This example will be very similar, but there will be very different things going on the right-hand side of the equation. To solve this equation for x, what I'm first going to do is add 2y to both sides. Adding 2y will eliminate this minus 2y on the left-hand side of the equation. The big difference is when I add 2y to this right-hand side of the equation, it doesn't add nicely to the 9 in any interesting way. Unlike when I added 6, 9 plus 6 is 15, that's easy. In this case, 9 plus 2y is just 9 plus 2y. Now what all I need to do is divide both sides by 3, leaving me with x equals 9 plus 2y divided by 3. Again, the only difference between these two is that fact that when I try to add 2y to both sides, which is an important step, it doesn't add in any useful way to the 9. And so on this right-hand side, what I get is, instead of a nice, neat number, what I get is an expression that has the other variables in my equation. Let's solve this equation for y just to see how it would be a little bit different. Now, if I'm solving this equation for y, what I would first do is subtract 3x to get rid of this term from the left-hand side of the equation. So I'm subtracting 3x. Again, my subtraction of 3x cancels the 3x's from the left-hand side of my equation. On the right-hand side, I have 9 minus 3x. Importantly, is I kept this negative 2 right here. That subtraction turns this into a negative value. I'm going to divide by negative 2, and I'll have y by itself. Last to say about this example, we often don't like having a negative in the denominator. I have two choices. I can put this negative out front, or I can give that negative to the numerator. I'll show both versions of that. So in this case, I've taken this negative and I've put it out front of the fraction. In this example right here, what I've done is distributed the negative to the 9 and the 3x, giving me a negative 9 now and a plus 3x. Here I have the equation for the surface area of a cylinder. I'm being asked to solve for h. What I'm going to do first is I'm going to subtract away this term 2 pi r squared. I don't care what's all in it. All I need to do is subtract whatever that term is, and I can move that to the other side. Again, adding or subtraction moves around different terms. So the action of subtracting 2 pi r squared gets rid of this term on the right-hand side of the equation. Now again, I'm trying to isolate the h here. There's no addition or subtraction going on. The only operations are these multiplications, the 2, the pi, and the r. I don't need to deal with those separately. I can divide these all at the same time. I'm going to divide this term right here by 2 pi r. Dividing by 2 pi r will cancel out these factors right here, leaving me with h on the right-hand side. And on the left-hand side, I'm simply left with s minus 2 pi r squared over the 2 pi r. Again, what I did was I subtracted 2 pi r squared to move this term. Then I divided by 2 pi r, isolating the h on the right-hand side of the equation. Whenever you're solving for a variable, you're asking what operations are occurring to that variable. If you have other terms that don't have your variable, you could add or subtract those to get them to the other side of the equation. Then you're left with one term with your variable. You simply multiply or divide as necessary the factors away to isolate your variable. Here I'm being asked to solve for r. This is a bit tricky because my r is inside these parentheses. What I'm going to do first is I'm actually going to distribute this p through the parentheses. When I distribute the p, I get p times 1 is p, plus p times rt is simply prt. Then what I'm going to do is I'm going to subtract p from both sides. I'm subtracting the p because I'm trying to isolate this term that has my r in it. On the left-hand side, I'll have a minus p. On the right-hand side now, if my p's cancel, I'll have just the prt. Again, my focus is on the r that I'm trying to isolate. Now I'm going to divide both sides by p and t because those are both being multiplied into my r, giving me a final answer of a minus p over pt equals r. To quickly summarize, when we're solving literal equations for a variable, we need to identify where that variable is. Then what we do is we're going to add and subtract around terms to isolate the term that has our variable. Sometimes what we'll have to do is to use distribution of multiplication or division until we've isolated the term that has the variable we're looking for, and then we simply multiply or divide to isolate the variable.